We present Video SnapCut, a robust video object cutout system that consistently performs well on a variety of difficult examples such as those shown here. These examples contain complex color distributions, weak foreground boundaries, dynamic backgrounds, and rapid foreground topology changes, and thus are very difficult for previous systems to deal with. Here we show an example of using the interactive video cutout system proposed at SIGGRAPH 2005 to segment the foreground football player. Since both the foreground player and background referee have the same white pants, this system is not able to distinguish between them using global color models, resulting in erroneous foreground contours even with lots of user scribbles. Furthermore, since segmentation is treated as a global optimization in the system, for difficult examples, new errors are constantly introduced when the user is fixing existing errors. Thus, the convergence of the system is difficult for the user to control. In contrast, our system performs well on complicated video scenes like this one. The user first provides a relatively accurate segmentation on the first frame. Then the system automatically propagates the segmentation onto successive frames. Note the high-quality foreground boundaries our system generates, even in areas where the foreground and background colors are not easily separable. Our system achieves high-quality segmentation by employing a new localized segmentation paradigm called overlapping localized classifiers. It consists of a group of overlapping windows around the foreground object boundary, each associated with a local classifier which only segments a local piece of the foreground boundary. To segment the next frame, the local classifiers are first propagated onto the next frame by SIFT feature matching, followed by optical flow estimation. Each classifier then generates a local foreground probability map at the new location by adaptively and optimally integrating local color and dynamically learned shape models. Finally, the local foreground probability maps are integrated into a global probability map, which is then fed into a graph cut segmenter to generate the segmentation on the current frame. A key feature of our system is the adaptive integration of local color and shape models for optimal segmentation. Here we visualize how the shape and color models are integrated differently in different local regions of the same object. For this local window, since the foreground and background colors are well separated, the local color model plays the dominant role in determining the segmentation. For this local window, since the foreground and background color distributions are overlapping, the system automatically relies more on the learned shape prior to achieve a good segmentation. Our system also provides a natural infrastructure for spatiotemporal local editing. In this example, the user lets the system segment 20 frames after providing the foreground mask on the first frame. The segmentation is generally good, however the shadow region on the surfboard is mistakenly segmented as background. The user then corrects the error on one frame using a foreground brush. Only local windows are affected by the brush, thus the segmentation is guaranteed to converge. Furthermore, the correction can be automatically propagated onto the following frames to correct the same error. In this way, by providing a limited amount of additional input, the user can quickly guide the system to the desired segmentation. After binary segmentation, a coherent video matting algorithm is applied to the extracted video object to generate a coherent alpha matte. This allows the extracted object to be seamlessly composited onto new backgrounds. In summary, we propose a video object cutout system that is capable of dealing with complex examples that previous systems cannot deal with. Our system provides a natural and fully controllable workflow for the user and is computationally efficient. Given all the advantages, we believe such a system is ready to be incorporated into real production.